Okay, this is part 2 of the task 4 video, and we left off where basically we had everything done here where we computed the complex number orbit and we graphed it and we got some intuition behind what was going on. So the way I want to just finish this up, I'm going to go ahead and do a little formatting here. I'm going to create the number format. Is just going to put number. I'm going to make this 3 decimal points. For this theta and radians, I'm going to do the same thing. Number format. Do 3 decimal points, and then some degrees. We're going to do number format. And then for here, maybe we'll just go 1 degree or 1 decimal point. So I'm going to take 1 away. And so let's go ahead and just, I'm going to copy these labels down here to our orbit section. Go ahead and center those. Just like up here, I'll go ahead and highlight and center those as well. And then I'm going to go ahead and, well, just use a different formula here. So like this one, we use the Pythagorean theorem to get R. In the back of the sheet on the project, we could also use im absolute value. So Excel has a function to calculate the actual absolute value. So I'm going to go ahead and use that here just to show you there was a different way to do it. But it should give us the identical number. Returns the absolute value of a complex number, left paren. And we're going to go ahead and do the same thing for these orbits. And then for theta and radians and degrees, we're going to go ahead and, well, for theta and radians, we'll go ahead and use im argument like we did above to get the complex number. And then we can get theta and degrees. I'm going to go ahead and use this degrees function, which is in the back here. Back sheet. Degrees theta converts theta and radians to theta and degrees. So we could either do the formula ourselves or use this function in Excel. Equals degrees of what's in cell G6. And then I could go ahead and copy these down to the 30 orbits. Sorry. And then I'm going to apply the same formatting rules here. Oh, sorry. Okay, so the formatting rules, we're going to just highlight these sections. Okay, remember one way to highlight is to put your cursor in the upper left area you want to select, and then hold the shift key down, and that'll anchor your selection range. Number format, and then we'll go to 3 decimal points. Oops. 3 decimals. Okay. So now we have everything we need. Okay, I'm just going to move this graph up here a little bit. Now let's just play around with this a little bit to make sure we think it works okay. I guess one thing we can check is if we only use real numbers, we should be able to reproduce what we did in task 3.1. So if we make the seed 8 plus 0i, and we make the rule 2 plus 0i, we can see that our number just goes from 8, 16, doubles every time. So the picture's not that interesting, but we can check the numbers here. I'm going to make this range a little bit bigger. We can see that that works okay. Or if I change this to 0.5, we should get 8, and it decreases by half every time. So it's always a good idea in spreadsheets to check easy conditions or easy scenarios to make sure you think things are working okay. So this complex number, when we make the imaginary parts 0, seems like it's doing everything we would expect it to be doing. So the next thing is I'm going to go ahead and put 2, 2 in here. And we saw in that first one that it spiraled inward because of the radius. So let's pick a different one here. Let's do like 1 or 0.9 real, 0.9 imaginary. It looks like they blew out the picture there. Okay, I was just checking. It looks like I actually had an error in my formula there. When I changed this fixed cell reference here to D3, I had forgotten to copy it all the way down. So back down to our 30th orbit, this still should be saying D34 times that D3. I think I had just done something wrong, so the picture was blowing up here. Okay, so what this looks like it's doing is it's starting at 2, 2, and then these numbers are pretty big in the axes here, and it's spiraling outward. And that makes sense because our rule is we're multiplying our seed by, in complex form, 1.273 at an angle of 45. So each time I do that, it should rotate the number 45 degrees and scale it out by 1.273. It looks like that's what it's doing. So let's see if we wanted to make this thing go in a circle. We could multiply it by something where r is going to be 1. And let's see, I'll do square root of 2 over 2. And square root of 2 over 2, we know that's a 45. That's the 45 degree angle on the unit circle. And that looks like it does spin around in a circle for us. And then let's look what happens if we do a rule, say just a negative number, 0.3. 0 is our rule. Looks like this thing just starts to bounce along here, along this line. Oops. Which makes sense because when we have a negative number, we're scaling it out by 3 and rotating it 180 degrees each time. Maybe to make that easier to see, if I made this negative 1.2, so it doesn't scale out quite so quickly, we can see that it's bouncing back and forth along this line. It's starting at the 2, 2, and so that's, again, maybe not as interesting. And so I'll just end this video here. I'm going to go ahead and put back 0.5 and 0.7. That was the example we were using, and that's a nice little spiral there. So what I'd like you to do for tonight then is to get your spreadsheet program to the point where you basically are doing this. You're doing a complex number iteration, you're getting the real and imaginary components off of it to be able to graph it, and then you're off to the side doing r and theta of the complex number so you can get some meaning to what's happening in the picture. And then we'll be in a good spot to do analysis on using our new tool. And I forgot to mention that once you're done, please again share the document with me, regardless of what time you finish it, so that I'm able to take a peek at it and make sure that you got to the right point. Thank you.